Hello and welcome. Today we're going to solve radical equations. This is the second part of the video. Here we're going to be dealing with equations containing extraneous solutions. So have out your notes and be ready to solve some math. First, let's talk about extraneous solutions in general. An extraneous solution is an apparent solution that does not satisfy the original equation. Always sub each apparent solution to check if it's extraneous. So let's look at what that may mean. So if I were to start with something, let's say I started with x equals 7, and I were to square both sides, because whatever you do to one side, you have to do to the other. So now I have x squared equals 7 squared, or x squared equals 49. If I wanted to solve for x again, I'd have to take the square root of both sides, which would mean x would be able to equal 7, or x could equal -7, because if I were to square -7, which would be the quantity -7 times -7, which would equal 49, or 7 squared equals 49. And we know either way that works. However, x equals 7, not -7, and we realize that because we started with that statement. Therefore, x equaling -7 would be an extraneous solution. So I think this topic may be a little bit confusing, so let's try a few problems. So what is the solution to n equals the square root of the quantity n plus 12? So the first thing we're going to do is we want to get rid of that square root. So to get rid of a square root, we always square. And if we're going to square one side, we have to square both sides. So we're left with n squared equals n plus 12. Now I want to get that all to the same side, and you'll see why in a moment. So I subtract n minus 12 to both sides, leaving me with n squared minus n minus 12 equals 0. And I know what you're thinking to yourself. You're thinking, it's a trinomial there. I gotta have to factor. So you have to think, gotta do some X games. The factors that multiply together to get -12 and add up to be -1, which you know with your enormous brain that it has to be -4 and 3. So that means n minus 4 times n plus 3 equals 0. Now let's think about what that means for a second. That means that one of those, or potentially both, has to be equal to 0, because the only way you can get 0 is if you multiply a quantity by 0. So we can write this statement. We can say the following: either n minus 4 equals 0, or n plus 3 equals 0. And what this means is that because it's an or statement, we only have to satisfy one of the quantities, right? We only have to have one of those to be true, which means n equals 4 or n equals -3. Now once we have these two quantities, we have to figure out, are there any extraneous solutions? So we plug that back into our original. So I'm going to erase all of this right here. We're going to start back where we had. We had 4 equals the square root of 4 plus 12, or 4 equals the square root of 16, which is true. We know that's true. The square root of 16 is 4. Then we use the other solution. We say -3 equals the square root of -3 plus 12, or -3 equals the square root of 9. But that would mean that -3 equals 3, which isn't true. So I know that n equaling -3 is an extraneous solution, and my actual solution is n equals 4. Okay, let's try another one. What is the solution to -z equals the square root of z plus 6? If I were going to do this, the first step that I always have to do is to square both of the sides to get rid of that radical, to get rid of that square root. Now, if I'm doing -z times -z, I can rewrite that as that's going to be what -z squared would be equal to, which would just be z squared. So z squared equals z plus 6. And just like the previous equation, I need to subtract z and 6 from both sides. So that gives me z squared minus z minus 6 equals 0. And the reason I do this is because then I can have that 0 statement, and I can also know that I just have to factor here. So I need two numbers that multiply together to give me -6 and add up to -1. So we know that's going to be -3 and 2. And remember, the negative has to be bigger there because I have that middle term is negative. So it'll be z minus 3 times z plus 2 equals 0. So that either means that z minus 3 is equal to 0, or z plus 2 is equal to 0. So z equals 3, or z equals -2. And of course, we're always going to check that out. So we plug that back into the original. So I'm going to have 3, comma, -2. Those are my two solutions. That's not a point. I'm just rewriting it there so that way I have that kind of as a list. So let us find out. So here I have -3 equals the square root of 3 plus 6, or -3 equals the square root of 9. Well, we know that the square root of 9 is equal to 3, so 3 does not equal -3. Therefore, 3 is not a solution that I can have. So let's try the other one. Here we have -2 equals the square root of -2 plus 6, or 2 equals the square root of 4, which we know to be true because the square root of 4 is 2. So our solution would be z equals -2. And that's all you have to do. The previous, rewind a little bit so you can get a little bit of help from the previous examples. Okay, so for the first one, you should have gotten that x was equal to 4. If you got -7, then you didn't plug it back in to figure it out. You should have gotten a equals 3/2. If you got those solutions and only those solutions, then fast forward to the next part. If not, then stick around and watch. So for this one, I know that to get rid of that square root, I have to square both sides, which will give me x squared equals 28 minus 3x. And then because I know I need to factor here to get my solutions, I get everything on the same side. I get that trinomial, which would be x squared plus 3x minus 28 equals 0. Then I have to think about, okay, what factors multiply together to give -28 and add up to be 3, which would be 7 and -4. So it would be x plus 7 times x minus 4 equals 0. So that means x plus 7 equals 0, or x minus 4 equals 0. I don't know why that's in parentheses. It just is. So then that would be x equals -7, or x equals 4. Now once I have those two solutions, right, because only one of them needs to be 0, so it's potential that both of them are zeros, and it could possibly be that only one of them works. So I need to plug them both back in. So -7 equals the square root of 28 minus 3 times -7, which would be 28 plus 21, or -7 equals the square root of 49, but we know that the square root of 49 is just 7. So -7 equaling 7 means -7 is an extraneous solution. Let us try the next one. Oh yeah, so then that would mean 4 squared equals square root of 28 minus 12, which would be 16. Oh, sorry, not 4 squared, just 4. So 4 equals the square root of 16, which works. So I know that x equals 4 is my solution. Let's try the next one. This one was probably a little bit harder, and that's where most of you probably got tripped up. So here, I need to square both sides, and that gives me 4a squared equals 4a plus 3. I subtract both of those over, which gives me 4a squared minus 4a minus 3 equals 0. So now I have to be thinking about what two factors multiply together to give me -12 and add up to be negative 4. The answer there is negative 6 and 2. So I'm going to break it down to 4a squared plus 2a minus 6a minus 3 equals 0. From here, I have to do my factor by grouping. Out of that first one, I can factor out a 2a. Out of the second one, I can factor out a negative 3. So that breaks it down to 2a minus 3 times 2a plus 1 equals 0. And that's pretty much the hard part there. So 2a minus 3 equals 0, or 2a plus 1 equals 0. Again, not sure why I have that parenthesis there. Okay, so that means 2a equals 3, or a equals 3 halves, or 2a equals negative 1, which means a equals negative 1 half. So I plug these back in. I'm going to rewrite them up there as 3 halves, comma, negative 1 half. And again, I'm not writing that as a point. It's just kind of my way to rewrite it to put it in there so I remember. And I don't have to scroll all the way down. So 2 times 3 halves is 3 equals the square root of 4 times 3 halves plus 3, or 6 plus 3. And the square root of that we know is the square root of 9, which is 3. So that would work. The other one would be 2 times negative 1 half equals the square root of 4a plus 3, or negative 1 equals the square root of 4 times negative 1 half plus 3, which is saying the square root of 1 is equal to negative 1, which we know that is not a solution. And we can kind of figure out a trend here, right? Whenever we have our square root equaling a negative number, that means that we're going to have, that's not going to be a solution. That's going to be an extraneous solution. If I were to have negative 7 equaling the square root of 49, I know that whatever number I have to plug in to get there, that is going to be an extraneous solution, because the square root of 49 is always going to be that positive number, right? Whenever we're taking the square root of a number, it always has to be positive. So those are those. Let's try to look at some with no solutions. So what is the solutions of the square root of 3y plus 8 equaling 2? Well, that would mean my first step here, of course, is to try to isolate that radical. So 3y equals negative 6. If I square that, if I square both sides to get rid of that radical, I have 3y equals 36, or y equals 12. Now, again, I always want to check, because if this were an extraneous solution, we need to know that. So I plug it back in, and I say the square root of 36 plus 8 equals 2. Well, the square root of 36 is 6, plus 8, that's 14. And 14 equals 2? No. So this one would actually be one with no solutions. And it's important for us to be able to kind of figure that out, that these ones are going to be no solutions. And that's why we always plug our number back in to check, especially when we're dealing with radical equations. So word to the wise, once you get your answer, plug it back in, because chances are it could definitely be a no solutions. Let us try, well, let's let you try these last two. So go ahead, pause the video here, and I will reveal the answers when I'm done, or when you're done. Okay, so the first one you should have gotten that y equals 1.5. The second one you should have gotten, if it'll select, no solutions. If you got both of these correct, stop the video here. If not, I'm just going to finish on with my explanation. So the first thing I need to do is square both of these sides, giving me y plus 12 equals 9y, because I have to square that 3, and I have to square the square root of y. So that would give me y plus 12 equals 9y. I subtract y from both sides, and I get 12 equals 8y. dividing by 8, I get y equals 3 over 2, because I always have to simplify. Double checking my answer, I have double checking my answer, I could plug that in, and I would realize that that would not be an extraneous solution. Let's look at the next one. I first subtract 3, so I have the negative square root of 4a plus 1 equals 9, and then I divide by that negative. Square root of 4a plus 1 equals negative 9. Here we kind of already know this is going to be no solutions because I'm trying to deal with a square root of a number equaling a negative. And I know that every square root has to be positive unless we're dealing with imaginary numbers. So if I wanted to double check though, I square both sides and I get 4a plus 1 equals 81. So 4a equals 80, which means a equals 20. But again, if I plug that back in, that would say 3 minus the square root of 81 equals 12. I got 81 because 4 times 20 is 80, plus 1 would be 81. Or meaning 3 times 9 equals 12, or negative 6 equals 12? No. So instantly I know once I'm taking a square root and I get a negative number on the other side, no solutions. So if you have any takeaway from the video, that's what it is. Thank you for watching. Make sure you took all the good notes, and if you have any questions, let us know.